Everyone, welcome to another episode. Today's question is first unique number. So you're given a queue of integers and you need to retrieve the first unique integer in the queue. So you need to implement this class basically. So we initialize the first unique class with some numbers in the queue, and then we have two operations. One is show first unique, which is going to return the first unique integer in the queue. It returns -1 if there is no such integer, and add inserts the value in the queue. Okay, I think before jumping onto the question, let me look at the constraints. So the length of the array, the key initial queue, is going to be 10 to the power 5, and then we're going to have 50,000 of at most calls to this, and then this is the nums and this is the value. So it's basically at max we can have how many numbers in the queue, which is 1 2 3 4 5 50,000 calls, right? So it's gonna be 1.5 into 10 to the power 5. That's fine, we can use a linked list or something. Okay, so let's understand the question. So it says initially the queue has 2 3 5, and then I query show first unique, so I print 2, right? Because 2 is the first unique for now. Then I have 5. Now 5 is already present, so it's no more unique, right? So let's remove it from this queue. Awesome. Next we get show first unique, again we print 2, and then we have 2, right? So 2 gets invalidated when we add 2, and then we have show first unique. Now 3 is the latest unique that we have, that is 3, and then we add 3, so 3 also removes because now it's no more unique. And then we have show first unique. Now there is no more unique in this, we return -1, right? Let's look at the answer. 2 2 3 -1, 2 2 3 -1. Cool. Let's look at the other example. It says 7 7 7 7 1 2 3 4 5 6 6. Okay, now first time I do show first unique, there is no unique number, so I print, this is the output from the previous example, I print -1. Then I do an add 7. 7 is already invalidated, not a problem. Then we add 3, so 3 becomes here. Then we add 3 again, 3 gets invalidated. Then we add 7. 7 is added, but it's already invalidated because it's already there in the queue, right? And there's no more unique. Then we add 17. 17 is there, show first unique, we're gonna print 17. So this is gonna be our answer. -1 17, -1 17, and all for others it's null. Awesome. So let's look at the problem, how we are going to solve. Let me take the example 2 3 5, right? The way I'm thinking is, because I'm going to code in Java, I'm going to use two classes. One is linked list, because operations on linked list to remove and all is O of 1, and then I'm going to use a hash map. So initially when I get the array for my first unique class, I'm gonna insert everything in the hash map. So I'm gonna insert the indexes of this, like 2 indexes 0, 3 indexes 1, 5 indexes 1. And if in the list itself, if I encounter any of the numbers that is duplicated, I simply change this indexes of this is to indexes to -1, right? We're gonna see in how this -1 is gonna be helpful. Now I have this stored in the linked list, right? Now what do I do when I get a show first unique? I simply take the head of the linked list and print the number, which is in our case 2. Now let's say I add a 2 to it. Now because 2 is already in the list, I invalidate this as -1. I remove 2, and that's all. Two operations I do. Let's say I add 2 again. Now I see that it's in the hash map and it's already -1, so I do no op. In case, because it's already invalidated, that means in the past I have already encountered a 2, so I don't care about it anymore. Now I ask a query show first unique, so I query this linked list and it gives me 3, right? Now again, if I add 3, I see it's in the hash map and it's not -1, so I erase the value out of linked list and I add -1 here. Now when next time I do add 3, I see it's already -1, that means it's already invalidated, so I do no operation. Now in the last case, let's say if I do a show first unique again, it's there is 5, I do that. If 5 gets added, I invalidate this value, right? Now I'm storing the indexes because if I have, in case so it's just a number for now. Basically I need to store some positive value in, and -1 if it's already invalidated entry. So I guess these two classes will be helpful in Java. Let's look at the implementation. um, so I'm gonna have two things: linked list of integer lst, and then hash map of integer comma integer. Right, when I get the numbers, I iterate over the numbers, and Java okay, what all methods do we have? Add, append the specific element. Right now we need to add it in the back, in the last, uh, basically because we need to make it act like a queue. So we need peak, retries but does not receive the head, the first element of the list. Okay, so we can do a peek on it to get the first element. Right now I iterate over it. Now is the, and I'm gonna insert, add nums of I simply, right, and that's gonna add it, and at the same time I'm gonna do add it to the hash map as well, which is nums of I comma I. Let's see. Now when I do a show first, if let's say if peak removes first element of the list or returns null if this list is empty, right? So if this list is empty, we can check the list empty by size also. Yeah, if lst.size is less than equal to 0, we return -1, else we do return right, the first element. Now in case of add, if the element is in the hash map already, in it contains the key. We erase the value and we put the value again as That's one. That means it's more. Else, yeah. Before erasing, we check if get, yeah. Get value is not equal to -1. So in that case, we need to erase from linked list, which is we can we can do remove index because we have the index stored in the hm, right? So we can do ls dot remove hm dot get value, because hm dot get value is gonna give us the index, right? And this index is same as what the number is stored at the list. No, but that could change. Yeah, we need so we can do index of first. Yeah, then we do LST dot remove index. So this is removed if it's not equal to -1, and then we erase it and we set it to -1. Now in this case, if not in hash map, we can keep a counter actually. We can just put it with positive value as 1, and we are gonna add it to the list, right? So we need to append it at the end. Add last, add pens to and add last, or actually add itself does it. So lst dot add value. So in this case, we add the value if it's not in the hash map, if it's already contains in the hash map, and if it's not equal to -1, we anyways are making it -1, but we need to remove it from the list as well, right? Because list peak is going to always give us a unique value. Now while inserting as well, if I encounter a duplicate value contains key which is nums of I, if it contains, we just do and then we remove it. Else we do this operation. Right, and then we do action. Okay. I think this looks good. Let's run it and see. think it's not erase. We need to remove. Yeah, remove this. Sorry, I'm using C++ concepts here. Um, why is it giving me an error? Index of value. Hmm. Let's see. I don't know why it's not able to find the value. Oh my bad. I was not looking at the line number. So this should be index of nums of I. Correct. My bad, my bad, my bad. 2, 2, 2, 9, 2, 2, 3, 9. Let's submit it. I hope it will pass. See. Okay, index of the okay, let's copy this example. Let's run it. See where we get the runtime error. Okay, next minus. Oh yeah, if I need to check if lst dot size is greater than 0, then only I do this operation of removing from. Otherwise, it's already removed, so I don't need to remove. I just remove it from the hash map, right? think same check here as well. Let me create a method. Public remove nums of I, and then similarly I remove so I remove this one. Remove I. Correct. Let's run the code. Awesome. So it worked, and then I submit it now. Okay, it gave me runtime error for some other issue. Yeah, I think we need this extra check here. Let me run this now. See how it performs. I guess expected answer. I guess we are getting the answer now. Awesome. So it got accepted. We needed that check that it should return an index of 0. So this check was not enough. Some for some values, let's say the list is not empty but the value is invalidated, so we need to check that it doesn't contain in the list already. So I hope you guys enjoyed this question. It was an interesting question. I struggled a lot, but at the end we were able to finish it off. If you guys like this video, please subscribe to my channel and give me a thumbs up. Thanks everyone.